So my name is Eldon Christensen, and I'm a program manager in the Windows Server division, and actually I own the failover clustering that you see in Windows Server, and I'm kind of your master of ceremonies, for lack of a better term. Actually, what you're going to see in this session is going to be everything new in storage in Windows Server 2012 R2. So we're going to cover all the incremental improvements between 2012 and 2012 R2. And we're going to try to give you the big picture. We're going to give you everything that we're doing across all teams. So there's a lot of sessions which are kind of drill down sessions. Like Brian's going to do a drill down session after this just on spaces. He's going to do an entire hour on spaces. But in this session, we're going to try to give you the roadmap of everything new storage. It's going to be a holistic view. And we're going to give you the entire storage map, everything from what we're doing in block-based storage, what we're doing in file-based storage, and then what we're doing from a management perspective across all of that. So this is going to give you the big picture. So we're going to talk about kind of the where we are today, kind of the changes, some of the changes we've made up in 2012, the road ahead with 2012 R2, and in there we're going to talk about management, we're going to talk about file-based storage, and then we're going to talk about storage spaces. So the journey so far, actually, as we think about, we made a lot of enhancements. So everybody's all at 2012. Everybody's got rid of all the 2003, 2008, 2002. Those don't exist anymore, right? It's all 2012. Because you got to get ready for the next release, right? Because it's only been 10 months, and you got to get ready for the next release because that's coming here before too long. So you got to get ready. But we did some great stuff in 2012. And if you look at some of the enhancements that we've made between, if I look at it from my perspective on the cluster side, we've done, large clusters, 64 nodes, 8,000 virtual machines. We've introduced Hyper-V Replica. So we now have an in-box disaster recovery story that'll work with any solution. VHDX, so we can do scalability with Hyper-V. NFS 4.1 with seamless failover. Seamless failover with SMB, continuous availability. Huge enhancements. Also on the System Center side, we can do block provisioning, thin provisioning, and SM API support. So big enhancements in 2012, which you're probably still adopting today, but great enhancements. That was a big turn of the crank. So that was a 3-year turn of the crank. A lot of big enhancements came in 2012. Now in 2012 R2, it's a much faster turn of the crank. So there's not quite, it's not as big of a roadmap as this, but we still have some significant enhancements we're going to talk about today. Two of the things I want to double click on. So there's two big shifts and kind of philosophical or strategic shifts that are happening with 2012. So if you aren't quite up to 2012, let me kind of just bring you up to speed on two of these big shifts. The first thing is that we have now embraced file-based storage in the sense of SMB being a protocol which you can use to run applications. There have been massive improvements in SMB in 3.0 in 2012. And it is not the SMB that your father used to know or your mother used to know back in the 2003 days. It is a completely different world. So, and the other shift is around spaces. So we introduced storage spaces, which is and actually, on the file-based storage, I'm going to talk about that. We also introduced a new kind of file server called a scale-out file server, which is really designed to be a back-end for applications running over SMB. So we have a totally new solution there. And then also a new feature that we have in 2012 is called storage spaces. And storage spaces enables you to take low-cost storage, low-cost commodity JBODs, and make highly resilient, available storage out of them and reducing costs. So we made lots of great enhancements in 2012. And a lot of these are about enabling enterprise customers. And we wanted to continue this journey also with System Center Virtual Machine Manager. So there were a lot of enhancements done in SCVMM 2012 R2 around performance. So there's great performance enhancements around enabling SMIS enumeration of drives. Also, we added fiber channel support. So if you've embraced virtual fiber channel, which was a new feature introduced in Windows Server 2012, that was not something you could manage with SCVMM 2012, not something you can manage through System Center, and now you can with SCVMM 2012 R2. Also, there were new features introduced in 2012 with like ODX, or offload data transfer, for enabling extremely fast, optimized file copies. And that is now lit up through SCVM 2012 R2. Okay, and with that, I'm going to bring up Hector from the SCVM team, and he's going to do a demo of some of these cool new features.
Thank you, Alden. All right, let me switch over here. See if we got the right one. Sorry. All right, well, good morning again. My name is Hector Linares. I'm a program manager with the Virtual Machine Manager team. So I'm going to take you through a quick tour of what we've done on essentially bringing a lot of enterprise features that Windows Server 2012 delivered in the RTM timeframe, now bringing those under management with System Center 2012 R2. So I'm going to start off first talking about synthetic fiber channel support or virtual HBA support in VMM. So what you have here in this view, this is the Virtual Machine Manager console. Right now, I'm in the Fabric workspace. And in Fabric, you've got servers, networking, and storage. These are the main areas that VMM manages from a Fabric perspective. And what you see now here is that we bring fiber channel fabrics under management. So I want to show you how we can do this as far as fiber channel fabric provisioning in the context of virtual HBA management and virtual VM deployment and also service template deployment. So I'm going to switch over to my VMs and libraries. Okay. So I've got two already configured service templates. And how many of you are familiar with service template, deployment through a service template? Okay. For those that are not familiar with this concept, this is something that VMM introduced in 2012. And this is essentially a model of an application, a multi-tier application that can have a web, line of business, and a database tier. And so in this case, I've only got a one-tier service with two virtual machines. So the way that I would start off this service instance is through what's called a service template. So I'm going to just double-click on the service template. And sorry, let me open up the designer. So this service template is essentially, like I said, one tier. With when you deploy it, we'll have two instances by default, and you can scale up and scale on these service templates. I want to show you within the service, the machine tier template, the hardware configuration. So in this case, I have the intent of a virtual HBA. So this is not actually an HBA that's been a VM that's been deployed. I'm just basically telling VMM when you deploy this VM, I want one or more virtual HBAs associated or configured with this VM. So I can have up to 4. I can tell it to use dynamically assigned worldwide port names by Hyper-V, or I can statically assign them at deployment time. And we've also introduced a concept of a fabric classification. This essentially allows you to say, I want my brocade fabric called production to be modeled as brocade, or in this case, brocade production. And when I run placement, I can find all of the hosts that have brocade production, or maybe the vSAN 01 is my Cisco fabric. So I need you to find all the hosts that have this Cisco fabric. So in this case, I'm not going to assign anything. So if I go off and deploy this and assign a fabric classification, what I end up with is a service template. Sorry, a service instance. In this case, I've got 2 VMs, and I want to show you the difference in everything that we actually line up to get the best deployment possible for a VM with virtual HBAs. So if I click on this VM that's powered off, and I go to the properties, so I'll show you again that I've got 2 virtual HBAs connected to my virtual SAN _prod. Now, virtual SAN is a Hyper-V concept, which allows you to group multiple fiber channel physical ports into a virtual SAN, and then you connect your virtual HBA to a virtual SAN. So since this is a deployed instance, I've already got it attached to a virtual SAN and some static worldwide port names assigned. Oops. So in the same properties, I can then go to storage and say I want to add a fiber channel array. So this is the first step that you get into where zoning is required. And if you're not familiar with zoning, essentially you're connecting the virtual HBA ports to one or more target ports on the array. That's essentially what zoning ends up doing. So you have to activate the zone set, and then you get to actually then unmask storage to that VM. So if I were to name my zone, pick one or more target ports, and then one or more virtual HBAs, and then hit create, we would actually go off and create the zone on the fabric. So I'm not going to sit through that configuration, but basically if I pop over to another instance where I've already done that, go to Properties, same storage tab, what you'll see here is that I've already got an array zoned to my VM, and then I can also have a LUN then unmasked to that set of VMs. So the onboarding is the zoning piece, and then if you want to do this for a service tier, you can also jump over to the machine tier, and that's the data tier in this case. Go to the Properties. I again have the same similar storage tab, and in this case I can actually unmask a LUN. So I can create a new LUN if I wanted to. I can unmask this LUN to all the VMs in the data tier. Okay, and so if you can do this 10 times, you can have a SQL tier with maybe 4 instances of VMs with 10 multi-terabyte LUNs already unmasked to that VM, and then you can create your shared, that's your shared storage for your failover cluster. So the other piece I want to show you is that with all the discovery that we do, if you get into a situation where maybe the VMs are not attached to the right vSAN, or maybe they're not attached to a vSAN, the other piece that we will help with is on the host side. If I click on the N08 host in the tree and go to, I guess right click isn't working here. Yep, go to Properties. What you'll see in the Hardware tab, in the same way that we manage network ports, so let's say this is a physical network port, we can then show you information about the logical switch that it's attached to. We can also show you information about the switch ports for the top of rack switch. So in a very similar way, we can then show the, in this case, these are some Emulex adapters. I've got 4 ports installed on my machine. I've got 2 ports connected to my Brocade prod. So this is my classification. And the actual fabric name is Brocade Fabric. This is something I named inside of VMM. So we can automatically discover all this information if you have the provider for the fabric switches and also eventually for the providers for the array. That's how we can align everything there. So in this case, I've got 2 fabrics, 1 Brocade, 1 Cisco. And so we'll be basically showing all the information for the physical port and what they're connected to. And then you can, when you start creating your virtual SANs, you can essentially pick which ports will participate in that SAN, in that virtual SAN. And in this case, since I could add, for example, more ports, since I know that this virtual SAN is already, I guess, configured for the Cisco's fabric, I can't pick my Brocade fabric, because there's really no point in picking a Brocade fabric if you don't want to connect to that, or if it's not the right connectivity. So you want to ensure that all the vPort or all the physical ports in a vSAN are part of the same virtual SAN. So we want to allow you to pick others that are not configured there. So that's that's our integration with virtual HBA and virtual SAN. We've essentially taken this a step further by allowing you to model the virtual HBA deployment through a service template, and then once you have an instance, you can zone the set of virtual HBAs to the SAN, and then unmask a LUN or multiple LUNs to the group of VMs that make up that data tier, if it's for example a database tier. Okay. So that was something that we just needed to do end to end, because the customer request was not only please support virtual HBAs, but also make sure that we have minimal friction as part of deployment of these VMs, and ensure that we can do all the zoning and all the storage management. So another top request that we get from customers is, how can we best optimize VM deployment? So Server 2012 in RTM introduced the concept of what's called ODX, offloaded data transfer. How many of you have actually been using ODX with your arrays? Okay. And so VMM today uses BITS, Background Intelligence Transfer Service. It's actually a great service that we've depended on for years. It allows us to make connections between 2 hosts without any AD integration. They could, for example, be in a DMZ or in some isolated protected network, and everything we transfer is over HTTP or HTTPS. Okay. Now, one drawback of that is that it takes time to deploy a VM. And typically what you would see in an ODX deployment, is that we would read data from the library to transfer the VHD. We would transfer the set of data over the network to the host, and then write that data on the host. So we would consume CPU, and we would consume network on both sides, on the source and on the target. So in this case, I'm trying to transfer so deploying a VM template, 8 gigs for the base VHD. It's a standard Windows build. And in about 30 seconds, I've got about 3% of the file actually transferred. So I'm going to cancel that, and what you've seen there is both spikes on the network side. So I'm going to now switch over to an ODX deployment using NetApp. And in this case, I'm using the same template, same source, same destination, same VHD. But what you'll see is in a relatively around the same time, maybe a few more seconds, not only can I deploy the entire VHD, but I can also create the VM, start the VM, and then have it go through customization. So we've only optimized, in R2, we've only optimized new VM from template to either a CSV or an SMB3 file share. There are other transfer types, for example, store to library, deploy from library, cold state migration where you're not using live migration on the Hyper-V side. And so those paths today are not optimized. We're only optimizing new VM from template to a CSV or a file share. So what you're going to see at the end of this deployment is that you'll see a few spikes going through when we finalize the VM creation, and then I'll bring up VM Connect, which will then show the VM actually starting up. So for us, this is a dramatic improvement from a deployment perspective, because typically this deployment, an 8 gig file deployment in a normal environment would probably take anywhere between 20 minutes to almost an hour. It just depends on how much traffic there is in the environment and the network connections between source and destination. So in this case, I do have everything on the same NetApp array, but what you're seeing here is a dramatic improvement from a template all the way to a running VM that's actually going through customization at this point. And if you've seen some of the demos from other partners where they can, for example, do multiple deployments in parallel and still get the same ODX level throughput. So one partner has EMC recently released a video of 30 gigabytes per second, right, for a single file. And if you have 2 files, they'll get 15 and 15. So it's still great transfer rates, all on the SAN without using CPU on the host or the network between the hosts. All right, and that brings it to the end of the ODX demo. And so I'll hand it over back to Christian. Eldon, sorry, thank you.
All right, thank you, Hector. Get back to there we go. Oh, all right, so let's talk about the road ahead. So we talked a little bit about what we've done in 2012, some of the enhancements we've done of continuing the journey on 2012. Now let's talk about some of the new enhancements in 2012 R2, a new scenario. So when we thought about, so 2012 R2 was a much shorter release cycle than with 2012. And when we thought about 2012 R2, opposed to trying to move the bar just a little bit, just a little inch on every single feature, instead what we decided to do was to take a more focused approach. So we decided we have a short turn of the crank. Let's take we just shipped 2012. Most customers are going to be very happy with 2012. Let's take some very focused approaches and deliver some value props end-to-end in some more focused scenarios. And we really focused on cloud scenarios. So we focused on private cloud scenarios, we focused on hosted cloud scenarios, and we focused on cloud service providers. So that was our real focus that we really tried to focus our efforts on. And when we thought about these scenarios, we really focused in on reducing costs. And we meant that both from a capital expenditure perspective and an operational expenditure perspective. And as we go through these feature sets, you're going to see how these all kind of tie into how we were trying to drive that direction. So I talked about how we introduced file-based storage in 2012. And I talked about how we also introduced spaces. But let's talk about one thing. This is kind of like there's anything you walk out of the session with, this is kind of the most important perspective I want you to get from here. We never really crispened up what is our vision of where we were going with what is kind of Microsoft's vision on storage for the private cloud. And so I just kind of want to articulate it. So first off, we have a vision around disaggregated compute and storage. So if you look at this picture here, I've got my Hyper-V systems. And so we wanted, and in our vision around reducing costs, opposed to doing scale up at the Hyper-V layer, at the compute layer, that's where you're hosting your virtual machines, we think about low-cost commodity servers doing scale out. So don't do big expensive boxes that are scale up. We're thinking about doing scale out and going out. Along this perspective, if you're going to do a scale out architecture, we want to have a commodity mechanism in these commodity servers to attach to your storage. And so when we think about, it can be price prohibitive to want to go stick like an expensive fiber channel HBA in each and every one of these servers. So we think about using low-cost commodity networking, such as like Ethernet. So we think about Ethernet or maybe even InfiniBand. And using this as a physical media type to get between compute and storage. And then our strategic direction around file-based storage is around SMB. We've seen a lot of things where some vendors are going with NFS as their strategic direction for file-based storage, and for us, we're going with SMB. And that gives us a lot of advantages, considering that we control the protocol and we can do a lot of innovation and really deliver some really compelling features, which you're going to see as we get into some of these features here. And then as you go over SMB as our protocol and Ethernet as our transport type, on the back end, we have our scale-out file server. So on the scale-out file server, we can deliver zero downtime. And then on the back end of the scale-out file server, we have block storage, which is servicing up to the back end. And our vision is around enabling low-cost commodity storage on the back end as well. And so we're enabling storage spaces to take cheap commodity JBOD storage and then create resilient storage out of them, and then we have very compelling storage features, and we'll talk about those at the end. So again, our vision about is disaggregated compute and storage. Ethernet is a low-cost transport from a scale-out layer to a storage layer, which is then backed by low-cost storage, and then using SCVM to manage this entire stack, top to bottom, soup to nuts. So let's talk about some of the storage innovation as we look at the R2 wave. So as you look at kind of the goals around storage management, right? You really want to have end-to-end discovery, end-to-end management. You want to be able to do bare metal provisioning. So when we think about this stack, we want to be able to deploy the Hyper-V systems on bare metal, deploy the Hyper-V systems, configure the operating system. We want to cluster them. We want to provision virtual machines on them. We want to be able to provision on the bottom end. We want to be able to provision the file server on bare metal, configure the scale-out file server. We want to be able to configure SMB sessions between the compute layer and the storage layer, configure SMB permissions. We want to be able to, on the bottom, configure spaces and the storage, and disaster recovery. So it's about doing that in a standards-based way. So that's a lot of our goals around kind of our vision around kind of the storage management. So one of the new enhancements in 2012 R2 is we have what we call our Storage Management API, or SM API. And what SM API allows you to do is we did a lot of enhancements around performance of it, but it's a standards-based way that we can do management of storage. So we can actually and if you look at it, that's actually how we're doing management with SCVMM. So we can manage spaces, we can manage SMIS compliant, or SMP older systems as well. So we can manage all devices, and this enables to have a layer of abstraction. So through SCVMM, we can manage any device. We're also using that through like Server Manager, and that's also the way we're encouraging all of our partners to actually integrate and manage storage through Windows. So if we look at some of the enhancements, actually I kind of just talked about this a second ago. If we look at some of the enhancements we have around SCVMM and managing, and these new enhancements in R2 around these new scenarios, We wanted to be able to manage not just and deploy from bare metal those Hyper-V clusters, but we wanted to be able to manage and deploy the Hyper-V as well, the scale-out file server in the middle, and we want to be able to configure the green layer in the middle, the SMB layer, and also we want to be able to configure and manage the spaces layer at the very bottom. So we want to have so that's one of the overall goals here that we now have in 2012 R2, is this entire vision and stack. We can now manage this through SVM top to bottom. We can do bare metal provisioning of everything and manage everything through a single pane of glass. Where before you were opening this cluster tool, then you were opening this disk management tool, then you were opening this other tool, and it was a very fractured experience. So now we have a complete management story, top to bottom, for private cloud deployment. One of our new features, one of our great new features in 2012 R2 is that we now enable a VHDX file to be shared between two virtual machines to enable guest clustering. So let me go back to, remember my description was talking about, we're really focusing on like our cloud scenarios, private cloud, hosted cloud. So our guest clustering story in the past was that you used either iSCSI or Fibre Channel and presented these LUNs up directly to the virtual machines, which you would use as a data drive to be shared between two VMs for a guest cluster. And our hosters were giving us feedback saying, we don't want tenants to have direct access to the storage. We want to have a layer of abstraction between the two. So now in 2012 R2, you'll be able to take a VHDX file, you present it up, it appears as a virtual SAS device through both nodes, and then you can use that as a guest cluster to fail over. For example, let's say you're going to run SQL inside of a virtual machine, and a failover cluster instance of SQL, and you want to fail over SQL from one virtual machine to another. And that enables it in a very flexible way. On the iSCSI software target, we've also made several enhancements. One of which is that, so with the iSCSI software target, you would create a VHD file, and you would present it up, and that would be presented as a LUN, as an iSCSI LUN for external servers to connect to. And we used the VHD format. So now we've converted over, and we now support using the VHDX format, and it's actually the format we use by default. So that gives us that gives us enhanced flexibility. So you can now provision larger LUNs, up to 64 terabytes. We can also dynamically grow LUNs, which is something we couldn't do before. And shrink. So that's a great power we got. Also, we wanted to enable the iSCSI software target in this end-to-end management story. And so we wanted to enable SMIS support with the software target so that we could do management through VMM, through SMAPI, over SMIS against the storage array. So this will give us an end-to-end management story. Nope. Okay, and with that, I'm going to bring Hector back up, and he's going to show us some of these new features.
So we're going to take a little break here for the password. All right, so I want to take a step back and just recap where we've been from the enterprise side, as far as bringing in a lot of the enhancements in management on fiber channel switches, fiber channel arrays. We've done this for iSCSI and SAS as well. So we're really talking about ease of management on the enterprise large scale and large-scale environments, and it's really something that we want to make it sure that it just works. When you plug it in, it just works. So if you look at more of the need for abstraction and maybe more of a software-based storage environment, one of the features that we introduced in SP1 is management of the Microsoft iSCSI target server. And so if you look at on the VMM side, if I switch over back to Fabric. So I've got a few arrays here managed by VMM. The one that I want you to focus on is the fact that this is, we got a bug in the UI right now, but this is the Microsoft iSCSI target that's actually managed by VMM. And the enhancements in R2 is that now we can manage a clustered iSCSI target server through VMM using the new SMI or the updated SMIS provider. So once we have this under management, now we can create LUNs and unmask them to either physical hosts or guests. And so, you do have the flexibility of in-box iSCSI target lens if the application requires it. Now, if we take that kind of approach and say, well, what else can we not only put in, make it, use the advantages of software, but what can VMM manage end to end? Now, file servers is something that we introduced management for in the last release, but we only discovered them. And we brought them under management. We assumed that you configured everything on your own, including the Spaces part. And so we had zero integration with Spaces. We were essentially compatible with systems that had Spaces already configured and set up, and with the file shares. But we essentially didn't do much aside from discovery and file share creation. So what we've done in this release is we've taken that a step further and said, let's actually deploy the physical servers that host the scale-out file server. How many of you are familiar with the bare metal deployment, or OSD, feature in VMM, Virtual Machine Manager? So today we can use, from bare metal, we can use technology like Pixie, Windows deployment services, integration with the baseboard management controllers. We can now even power on physical machines, boot them, make sure that they boot from Pixie to WDS, and we can start, we'll bring a WinPE down, we'll download WinPE, and we'll start installing the OS using boot from VHD. So we can take down a typical VHD that you would have in your library, even for a VM. We can bring that down to the host, configure boot from VHD, and then run that through customization. We can do that multiple times, and then actually install the failover cluster. So if I switch over to my library view, so if you're familiar with this feature, then you'll know that we had host profiles in the previous release. We've made that generic, and now we have what are called physical computer profiles. And so if I create a physical computer profile, oops. So what you'll see here is that I can give it a name, some description, but I have two roles to pick from. I can either make this a VM host profile or a Windows file server profile. We've made the primitives generic so that in the future we could potentially deploy other roles, but for now, these are the two roles that we deploy through VMM. So when you would go through this, you essentially pick the VHD that you want to use as your operating system. And again, this can be any standard sysprep VHD or VHDX sitting in your library, even the ones that are used for virtual machines. You tell us how you want to configure the NICs. So if you're familiar with common device naming, it's essentially a way that you can, on a physical machine, you can tell us specifically which NIC you want to assign an IP to. And so we use deep discovery for that using WinPE, and then that's how you get your static IP configuration without having to know the MAC beforehand. You basically just say, for any ports that are named in this standard way, I want this to be my port that I have for with this IP address. And this also includes the OS disk configuration. And then we also have a set of properties that we keep for the unattend.xml, domain join, passwords, product key, etc. So the end result of this is something that I can then use to stamp out multiple physical machines. So I'm going to switch over back to my fabric view. I will then, in the ribbon, go to Create, and then I'll click on File Server Cluster. So in this space, I'm actually going to now name the cluster and the scale-out file server role. So these are two endpoints on the network, and they have different IP addresses. So I would give, for example, the test cluster name. I would say I want my scale-out file server. And then I would essentially run through bare metal deployment. So I want to show you two paths that you can have for cluster creation. You can either start with existing physical machines that have an operating system, already on network, already deployed, and if you pick for the first option, you essentially give us a list of names of the computers. We'll go off, enable the file server role, enable the failover cluster role. We'll cluster the machines and also create the scale-out file server role instead of failover clustering. So we'll do all that work for a machine with an existing operating system. The more interesting one is if we do bare metal deployment. So in the second option, now I can pick that profile that I created before, and now I can actually run through the bare metal deployment of first. Tell me, you have to tell VMM which BMCs to actually use. So in this case, you're going to tell us what protocol We need to communicate with the BMC. I'm sorry, if you're not familiar with baseboard management controllers, I'm essentially talking about the HP ILOs, the Dell Dracs, et cetera, and essentially the devices that sit on physical servers where you can power on, power off, get some information about the system without there being an operating system. So I essentially need an account to access the BMC. You pick your protocol, and then you essentially tell us either a direct one IP, a range of IPs, or a subnet to look at. And then we'll go off and enumerate all of those BMCs, and then you can select all the machines that you want to deploy. So the end result of that is essentially a fully configured scale-out file server cluster. And so at this point, there's really nothing else to do on a clustering side. Now we can go and manage the storage. So for this cluster that I've already deployed, I'm going to go to the ribbon and click on Manage Pools. So from a managed pools perspective, the first thing we got to do is actually do physical disk discovery. And so with the new cluster aware spaces provider that's a part of R2, and that's what we use to do this integration, we can actually go off and enumerate all of the physical disks that are attached to that cluster. So this is a small environment. It's only got a few disks. You could have hundreds of disks potentially attached to this. So you would say, I want my demo 3. I'm going to pick my physical disks, and I'm going to assign a classification. Classification is used by VMM as a way of landing a VHD on a certain type of storage. So if you want to name your, in this case, your storage gold, from a self-service user perspective, they don't have to know which file share, which LUN, which cluster, which host they need to land on. You get the ability to say, from a cloud perspective, you get gold storage, and you get this much gold storage. And then placement will go and find all of the appropriate hosts that have access to gold storage. So I'll create my cluster and hit OK. So this is done, we essentially go to the back end and create the pool from the physical disks. And once this job is done, there you go. Once this job is done, I can then go on back to the ribbon and say create file share. So this piece is what we call intent-based file share provisioning, where what you're going to see here is that we're going to orchestrate the creation of the space. We'll attach it to the file server cluster. We'll make sure that we initialize, partition, format the disk, and then we'll bring that into the cluster as a CSV. Once it's a CSV, we'll then land a file share, a scale-out file share, on that CSV. So we've done all of that work under the covers. So you basically say test share. You pick the pool, and I'll pick demo 3, which is the one I just created. You have the option of picking another classification. For example, if I want to make this silver or bronze, you have the ability to override now classification at the file share level. So if you, for example, have one file share that's using a parity space and another file share using a mirror space, you can differentiate those if you choose to. Otherwise, they all inherit gold. So I'll pick awesome demo and then give it a size. So what we do in the back end, if I flip over to the cluster, oops. So in this case, this is a cluster with an existing, essentially 1-for-1 for every share that I have created. In the back end, we'll go and create the space. We'll bring that space into the cluster as a CSV, and then we're going to land, from a role perspective, we'll land the file share. So you'll see here the file share show up. And then what I can do with that final step, once the file share is available, there we go. Now the test share is available. I can go to the servers, right-click on demo cluster. Whoops. All right, let me just click on demo and properties. All right. Almost there. There we go. I can now assign that share to the cluster, and in this case, we're doing the ACLing work to ensure that you have that the set of nodes have access to the share. So that will be my test share, and then we will do all the ACLing work, and then you can land all your VMs now on that new share or multiple shares. All right, switch back to Eldon. Thank you.
Thank you, Hector. So that's pretty cool. Right? He just did a total bare provisioning of a scale-up file server, configured all the storage, end-to-end management. All right. Let's talk about file-based storage. So if you look, I kind of drew a box around kind of in the middle of what we're going to talk about in this next section, talking about the SMB layer, talking about the scale-out file server and enhancements to having a low-cost storage fabric. So if we look at the middle layer, let's talk about SMB performance enhancements. So SMB Direct is about using an RDMA-enabled NIC to offload to the NIC to get significantly better performance. So we see actually a 50% improvement in small I/O workloads with AK workloads, with AK IOPS. We also have increased efficiency with these when doing SMB Direct. So you're going to see this is just improvements you're going to get for free by going with 2012 R2, is that you're going to see AK IOPS have better performance and efficiency. So we also did some enhancements around trying to optimize the scale-out file server. So one of the things we do, so let's talk about, we'll kind of go bottoms up. So from a CSV perspective, so let's say you have, so cluster shared volumes, which is CSV, has one of the nodes which is, we kind of deemed the coordinator node. It's a clustered file system, and you need to do orchestration of changes and updates to the file system. So what we do is that in the past, you can actually end up, we have a orchestrator per one, and you could actually end up, and let's say you had 10 disks, and if you had 10 nodes, you probably just want to spread those out across the cluster. And we really had no logic in the past to really make sure they stayed spread out. So that's one of the new enhancements we have in 2012. R2 is that we will go and just kind of push and spread out those CSV volumes out across all the nodes in the cluster to make sure there's better distribution. The other enhancement we have is that we will actually detect when SMB sessions are connecting to the scale-out file server, they will detect to see if they have an optimized I/O path where they can do direct I/O. And what they will actually do is that when we go and connect, we will then seamlessly transition the SMB session. So when you connect into the scale-out file server, maybe you'll get connected to node 2, but really a better node where you're going to get more optimized I/O performance might be at a node 4. So we're actually going to seamlessly transition that SMB session over to node 4 to make sure you get the optimized I/O performance. And this is all going to happen automatically under the covers and enable the scale file server to achieve the best balancing across the cluster. So let's talk about live migration with SMB. So that's one of the new enhancements. So now in 2012, so there's kind of 3 options you're going to see for live migration. You're going to see the traditional live migration that you knew in 2012, which I thought had pretty good performance. But if you compare it to the optimizations that we've done in 2012 R2, you can turn on compression now, and that will give you significant performance enhancements. And then we also enable running live migration over SMB as well. And the real value prop there, when do you want to run live migration over SMB, is if you have an RDMA-enabled NIC. So if you have an RDMA-enabled NIC, you can do a lot of the CPU offloading to the NIC. So the performance, the CPU hit of doing a live migration is not nearly what it is when you're doing compression. Also, if you're doing SMB multi-channel, so one of the cool new things with SMB 3.0 is that you can actually stream across multiple NICs and get the aggregated bandwidth across multiple NICs at the same time. With SMB, doing live migration over SMB, you can actually take advantage of that. So if you want to stream a live migration across multiple NICs and get aggregated bandwidth, you're going to get a big advantage there. So scenarios when you think about you doing live migration over SMB is around if you have RD-enabled NICs or if you're doing SMB multi-channel, you'll get a huge value prop there. So let's talk about SMB bandwidth management. So SMB is starting to become a common infrastructure for many pieces. So even if you look at cluster shared volumes, SMB is a protocol transport that we use as infrastructure for doing I/O forwarding between the nodes in the cluster. SMB has now also become a storage protocol, which you're using for connectivity down to your storage to run your virtual machines. It also can be used as a protocol for doing live migration between nodes in the cluster. And it also can be used for just doing basic file servicing. You're going to go copy a VHD off of an SMB share, off a VM library, and copy it down. So there's many different types of ways that SMB is being used, and we wanted you to be able to have some management of how that bandwidth is being utilized. So now in 2012 R2, you can actually say, you can actually do some, you can set limits. So let's say for my storage on the back end, I could say no limit. I want that to go as fast as possible. I want I/O performance for my virtual machines. When I have this burst traffic for live migration, that's important, but don't let that completely saturate my system. Let's restrict that a little. So you can set that, like in this example I said, it's 500 megs per second. And then for my VM library, if we're doing a file copy down from a VM library, that's maybe not that important, right? So maybe that we're going to restrict that even more so that it doesn't consume all the bandwidth. All right, let's talk about Hyper-V online resizing and storage quads. So one of the new features with Hyper-V around storage is that with a VHDX file, you can now actually dynamically expand or shrink a VHDX file with no downtime while the virtual machine is up and running. So that's a huge enhancement. A big ask we had from customers was saying, anytime I want to grow VHDX, I had to shut down the virtual machine in the past, and now you don't have to do that. There's also storage quads enabled at the VHDX layer. So you can actually set the maximum amount of IOPS that an individual VM is allowed to do to a VHDX. So if from like a hoster perspective, if you have a individual tenant VM which is saturating the storage array, you can actually restrict it to how many IOPS it's allowed, and you can and actually set different service level agreements and quality of service on what you want so you can have a gold or a bronze or a silver. And you can set alerts on when VMs are not getting their IOPS satisfied. And then we have some metrics that you can go and check for the VMs as well. Okay, and with that, I'm going to hand it over to Jose, and he's going to do some demos of some of his new cool features.
All right. Thank you, Evan. I was just warming up my stuff here so I don't take too much time transitioning. We are going to do a little demo here. So I have a 2-node scale-out file server cluster you can see here. And I'm going to just put a workload on it, okay? So I'm running some simulated SQL workload. And then you can see here something very interesting if you look closely. So this is a 2-node file server cluster. This 2-node file server cluster has only one client accessing it. And I'm monitoring the 2 nodes for activity. And a single client is now actually hitting both nodes at the same time. If you understand how the scale-out file server works in 2012, you know that each client chooses a node and a node only, right? So you never would see this in 2012. Now a single client can do this. How is it doing it? We're doing per share scale-out selection. So we select the node that's best for that share. And if you look at how my cluster is currently configured, if you look at the list of disks, you'll see that I have 3 CSVs in one node, and I have 3 CSVs on another node, and I have a share on each one. This was not something that I set up. It was naturally done by the cluster. So now the cluster knows if I have 6 CSVs and I have 2 nodes, I spread them around. And that happens automatically. Now, what I wanted to show you is taking this one step further. How about I add a node to this cluster to see what happens? Now, how do I add a node to the cluster? Obviously, using VMM. So now, VMM manages the cluster, right? So you can see that I have my file server here with some gold shares, some silver shares. And I'm going to go ahead here, right-click, and say Properties. And you're going to see that my cluster has 2 nodes. We knew that already. Now I'm going to go ahead and say I want to add Jose-A3. I'm going to go ahead and say, okay, I want to add a node to this cluster, okay? And I'm going to go say, okay. So what's going to happen here is going to start to have some activity on the VMM side, and you're going to see that VMM is now already busy doing everything that needs to be done here so that we get that there. So if you look at the details here, you'll see that it's preparing the node, it's installing the agent, it's adding the role for the file server cluster role. It's adding the failover cluster feature, and it will eventually add that node to my cluster. Okay? And I can do it from VMM. It will just work. We'll come back to this. In the best tradition of the cooking shows, we're going to actually leave this here. I'm going to switch to this other machine to do another little demo while we wait. Performance demos. Who likes those? Let's talk about SMB Direct. So I'm going to start by kicking off a little workload here that does 8K IOs. I want you to look at this number here. This is a single client talking to a single server that has 48 SSDs in a single space. Okay? It's actually a mirrored space. Not sure if you're noticing, but we are doing nearly 600,000 8K IOs per second. That's a lot of IOs. Okay? And it's actually better than we could do in 2012. And keep in mind, this is our stack, shared JBOD, spaces, SMB server, over the wire, other side, SQL running, right? So we passed 600, did you see? For a second there, okay? Yeah, there you go. Cool. That's one thing. Now, I'm sure you heard that we're also doing caching, right? CSV now has this great thing called the caching, and now it can dedicate up to 80% of the RAM in the file server for caching. And if you have a certain workload that does caching, what you can do is you can avoid the issue of having to go to disk and back, and that can really improve your performance. So that's the same system, okay? I'm still doing 8K IOs. Now, granted, I'm not going to disk on this one. I just want to show the power of our networking stack, okay? That's the goal of this piece of the demo. We are doing, I want to say, nearly 1 million remote IOPS. So that's SMB client, over the wire, SMB server to RAM, okay? What's the bottleneck here? It's CPU, okay? No, the cache is something you have to configure because you tell us how much of the RAM you want to use for caching. Yeah? So yes, you do have to configure it. Yes. Eldon has a great blog post on that. Yeah, so 32K IOs. I'm glad you asked. So that's exactly what I'm going to do next. So, I didn't plant him, I swear. So what's happening here, right, is we are really good at large I/O, right? RDMA excels at large I/O. This is kind of an interesting demo. I used to do like 512K IOs for like large throughput. Then I started doing 128K. Now, this is not, I don't want you to focus on the IOPS number. I want you to focus on the bandwidth number. On that same system, from disk, so mirrored space, 3 NICs, other side, workload. We're doing 16.5, give it or take, gigabytes a second. Okay? For perspective, that's 10. If you're doing 10 gigs, that would be 15 10-gig NICs. If you're doing 8 gig fiber channel, that's how many? At least 20, right? This is 3 InfiniBand adapters because we're doing SMB Direct and multi-channel at the same time, okay? This is 500,000 32K IOPS. Okay? I know you hear a lot of folks doing million IOPS out there. Million IOPS, when you dig deeper, there's a 512 byte I.O. being done, and sometimes going to raw disk. This is our full stack. There's NTFS here, there's spaces, it's mirrored, so it's a usable set of disk space. This is real. And I am doing this right now on a live system. Okay, let's go back to our demo. So CVMM is done. Look at what happened. I love how we don't have to actually do much. We just add the node. What happened there was CSV rebalanced the cluster. And now, if I go back, sorry, to my nodes here, you'll see that I have 2 volumes on A1, 2 on A2, 2 on A3, and then my witness disk. That's on A2 as well. Okay? So that's how simple this thing is, right? You just add the node, it rebalances. For a little twist, just so you kind of get the inception notion of what's going on here, this cluster is actually done entirely with virtual machines. My demo here, I am actually running on this machine with Hyper-V, and I don't have a nice SCSI target. You know how I'm doing this? I'm going to go here for settings. I have one boot VHD, and I have 7 data VHDs. There's a special thing about them. It's a shared virtual disk, right? I'm doing this just for the demo. I'm just showing the capability of our platform. You have the ability to now share VHDX and create guest clusters as well. Make sense? I have an awesome live migration demo, but we're running short on time, so I'm going to hand it back to Eldon. And if you want to see the live migration demo, we have it recorded on the session that I did on Monday. So take a look at that one. It's really cool.
All right. Thank you, Jose. All right. So let's talk about deduplication. So a couple enhancements around deduplication in Windows Server 2012 R2. So the first thing is that with the V1 version of data deduplication that was introduced in Windows Server 2012 was an amazing feature and could really get you some serious space savings. However, it only worked with files which were not open. It worked really well for like a VM library. If you had a VM library with a whole bunch of VMs which were not being accessed, that you could dedupe those and get great space savings. But customers really incredibly love this feature, and we got some strong feedback that they want to use this also on running VMs with VHDs, which are live and open files. So that's one of the huge enhancements in 2012 and around deduplication is that you can now dedupe a live file. There are also a lot of performance enhancements around that initial optimizations and reads and writes of these optimized files. And then compatibility. So another one of the big gaps in 2012 was saying, love dedupe, want to run it on live VHDs. Oh, and by the way, almost every Hyper-V deployment I have is clustered, and everyone is using cluster shared volumes. So we need interoperability with cluster shared volumes, and also this plays into our overall end-to-end story of our private cloud vision on how we have Hyper-V over scale-out file server with CSV on the back end. All right, you ready? And with that, let's do a demo on dedupe.
Hi. Hello.
You got to turn it on. It's not on.
Hi, my name is Giridhar. As Eldon mentioned, we support live deduplication in Windows Server 2012 R2, and also we support deduplication on CSV. So with dedupe, we do a lot of things, like when there's a data access on a dedupe file, underneath we have a filter driver which kind of assembles chunks and then serves it back. With this, there is bound to be some impact with dedupe. So the demo that I'm going to show today is a boot demo, which is kind of critical for VDI deployments, where a 9 a.m. Boot is something which is so this is the bootstorm scenario, where everyone comes in at 9 a.m. Monday morning, tries to boot in. With dedupe, let's see what the impact would be. Would there be any impact, or would everything be fine? So for that, let me bring up Hyper-V Manager. So here I have two. The font is kind of small, but here I have like two collections. One is VMs out of deduped volume. The other collection is VMs out of normal or non-deduped volume. So I have like 5 in each of these collections. And I also have a simple application here which boots these VMs simultaneously, in a sense creating a bootstorm. While I actually run this demo, I also want to capture some perf counters. So before I start the perf counter, I also want to show you that I have like 2 VMs here. One from dedupe and normal collection. These are the last VMs of those collections. Now let me start the perf counters. And I'll put all these VMs. So you'll see that VMs from each of these sets start one after the other. Now all the VMs are in the running state. You can keep an eye on these VMs here. So here the perf counter basically shows, the red line here shows the reads that are happening on a normal volume, and the green line here shows the reads that are happening on the dedupe volume. So while these VMs boot, let me just explain a bit about what's happening when there is access to deduped file. When Hyper-V sends a read request onto a dedupe file, there is a filter driver that we have which intercepts this read, redirects the I/O to the chunk store where the chunks are residing. In chunk store, the chunks get reassembled and then served back to Hyper-V. You would be aware that Hyper-V does Hyper-V does unbuffered I/O to. It basically does unbuffered I/O, which bypasses the system cache. But what dedupe does in the background is, when it does a read from the chunk store, it does a buffered read, in a sense caching these chunks into the system cache itself or in the RAM. So if there is a another read that happens, the read gets served from the system cache itself. So you'll see that most of the dedupe VMs are already booted up, and the normal VMs are still booting. And the reason for that is, as I explained, with high deduplication, most of the chunks kind of end up in the system cache itself, with reads getting served from system cache. And that's evident from, so now all the VMs are booted up. Now you can see that that's evident from the perf counters as well. If you see the read bytes, on the normal volume, the average read bytes is around 15 million bytes, but in case of dedupe, it's around like 5 to 6 million bytes, which is like, there is a like 1/3 reduction in reads. That's it. Back to Eldon.
All right, thank you very much. All right, so let's move down the stack. Let's keep going down the stack. So we talked about SMB, we talked about the scale-out file server. Now let's go down and let's talk about block storage on the bottom with spaces and JBODs. All right, so enhancements that we've made. So spaces was first introduced, a new feature introduced in 2012. enables you to take low commodity JBODs, just a bunch of disks, and create a resilient storage out of them. So some enhancements we've made is around mean time to recovery with a disk failure. So if you have a disk failure, we now do parallelized recovery with a mirrored space to give you much better recovery time. And you'll have increased throughput when doing this. You'll have optimized disk utilization when doing rebuilds. So the rebuild times are significantly faster than they were in 2012, with 2012 R2. So here's one of the huge features in 2012 R2. This is one of our gems, is that we now have tiering built into spaces. So you can take a space, and you can have SSDs and HDDs in a pool, and we will intelligently use them. So we will have tiering where we will basically heat map the data, the data access, and then we will actually move at a block level data up and down between tiers. So we will move data up from, so we'll move hot data from spinning media, from HDDs, up to SSDs to give you increased performance. And in turn, we will move the cold data down from the SSD tier down to the HDD tier. You can also pin files. So we will do this on a 1 megabyte block level. So we'll move on a sub file level, 1 megabyte block level, data up and down from the tiers, automatically from SSDs to HDDs and back and forth. We also give you the power and flexibility to pin files to the tier level you want to. So let's say you're doing a VDI scenario and you have your entire gold VHD, and you're saying, nope, this is my gold VHD. I want to pin this whole thing to the SSD tier, not just the hot blocks, but I want to pin the whole thing. You can do that. So at a per file basis, you can pin files to the HDD layer, or the SSD layer, or the HDD layer, whichever you choose. So that gives incredible power. Another thing that we have is a write-back cache, is that you can use the SSDs in a space to be a write-back cache. So that when you go to do a write, so when the VM is going to do a write, it will actually come down, hit the SSD layer, and get acknowledged. So you're going to get very fast write acknowledgments, and then it will lazy move the data down from the SSD tier down to the HDD tier. So when you kind of combine those two things, you're getting the best of read performance through tiering, because read performance is going to be optimized. It's going to make sure that those hot blocks that you read the most are on the SSD tier. And then you're also going to get very fast write performance, because those writes are going to be acknowledged fast from the SSD tier and then written down cold to the HDD tier. And with that, I'm going to hand it over to Brian, who's going to show you some of these cool features in action.
Thank you, Eldon. Good morning, everyone. So I'm going to show you a couple demos here. First one is on the write-back cache. So the write-back cache absorbs short-term bursts of random write activity to your virtual disks. Now let's prove this. I'm going to start my demo. You can see I have two perfmon windows. One perfmon window on the right is showing perf counters for a volume without a write-back cache. The one on the left showing a volume with a write-back cache. You'll see I have workload running on both volumes. That's indicated by the blue line. That workload is doing roughly 550 IOs per second. This is the workload I really care about. Superimposed to this blue line, I'm not really sure you can see it right now, is the total IOs per second delivered by each volume from that quote-unquote blue line workload and from any other workload that I'm going to introduce. The write-back cache absorbs these short-term writes. Let's introduce short-term writes to both volumes and see how it's handled. So I just introduced a write burst on both volumes. As indicated by the dotted red line, more work was done on both volumes because I had my blue line workload and I had my writes I was doing. On the volume without a write-back cache, you can see I had a significant drop in the performance of my blue line workload. This is because I didn't have a write-back cache to help absorb that. On the volume with the write-back cache, my workload continued to run smoothly. Let's introduce another write spike. And another write spike. You can see on the volume without a write-back cache, the workload was affected by that write spike, and the volume with the write-back cache, it was smooth. Write-back cache is doing its job. Let's move over to the tiering demo. What I'm going to show you is the seamless transition of a file that is currently completely on the HDD tier to the SSD tier. Now the kicker here is that while this transition is happening, I'm going to have an intensive I/O workload that's running to this file. High queue depth, high number of threads. Another perfmon window popping up here. I'm doing my I/O test to this file. It's right now on the HDD tier. All the blocks underneath this file are being serviced from the hard disk tier, and it's delivering me roughly 2,600 IOPS. I only have a few HDDs here, so this is about what you'd expect. Now I'm going to kick this file on over to the SSD tier, and let's see what happens. So I've just processed the movement request. I've requested the file system to immediately initiate processing. Now, typically, processing and movement would happen in a daily scheduled manner, which is configurable, but I can immediately kick off that if I want this file to be moved right away. So you can see already the IOs per second service from my intensive IO workload to this file are increasing. This is because the file system is moving the blocks that underlie the file to the SSD tier, transparent from my workload. Now it's really starting to scream up here, and it's done. All the blocks that underlie this file that were previously on the HDD tier have now been moved completely to the SSD tier, all the while my intensive workload was running to the file. You can see during the process there was no or negligible dip to the performance of my I/O workload, and the movement happened quickly. That is tiering. Now we do this. We can do this. You can specify files to be placed on tiers, or you can have placement done automatically based on heat. So we give you the control whether you want heat placement or you want to control the placement. Now I'm going to hand it back on to Eldon.
Oh, I waited to say something before we got past the speaker. Almost became a feedback showdown there. All right, thank you very much. So again, Brian, we just did 5-10 minutes on spaces. Immediately following this, he's going to do an entire session just on spaces. So I encourage you, if you want to learn more about spaces, in the next 30 minutes, go to his session. You're going to learn a whole lot more.
It's in 393.
393 all the way. So it's it's like a mile walk, but it's a mile walk, but it's 30 minutes away. All right. So let me, in summary, let's close this back up and just kind of loop this back together. So again, I just want to talk about our vision around private cloud storage, right? It's about disaggregated compute and storage. It's about low-cost commodity Hyper-V systems that scale out using a low-cost storage interconnect in each one of those scale-out commodity servers down to your storage using SMB as a protocol. Jose showed you today's SMB is not the SMB you knew in the past. It has totally changed in 2012. It is even better with 2012 R2. It is two different things. So don't think about what the SMB 1 or 2 that you maybe knew in Windows 2003. It is a whole different ballgame. It is incredibly performant. We talked about the scale-out file server and how we're intelligently balancing that and using as file-based storage. And we talked about spaces, and we're talking about how we're delivering we have spaces to give resiliency to the storage, and now we're really delivering some of the really compelling write-back caching, tiering, the high-end features you expect out of your storage, we're delivering in box. And most importantly, this whole thing, end-to-end, is manageable with System Center. So no more having to jump around consoles. So again, we're reducing costs from a hardware acquisition position in the server level, in the interconnect level, at the storage layer, and we're reducing operational costs because you can do it all end-to-end, every piece of this, top to bottom, from Hyper-V to scale-out file server to your storage to SMB to everything through a single pane of glass and a single management tool. So that's a new experience for us. All right, and with that, I want to say thank you very much. And if there are questions, we're open to questions at this point. All right, thank you.